So hello everyone, my name is Ashley Grupenhoff and I'll be talking to you all about the Springs Fire case study. And I'll be expanding a little bit on Joe and John's talk earlier and go into a little bit of detail on this specific example of science and management collaboration. Just a little bit about me, I'm a current ecology PhD student at UC Davis working with Hugh Safford. My work is primarily focused on current prescribed fire practices across the Sierra Nevada. So for the past 2 years, I've been working with Joe and John, helping to run the monitoring program, looking at variation in fire behavior and the effects of prescribed burning on reducing fuel loading and restoring natural fire patterns back to the landscape. So as most of our talks are talking about today, fire is a natural process in many forests in the Western United States. Indigenous people have been putting fire back on the land for millennia. A century of altered land management practices have resulted in overgrown forests, increasing the number of massive, catastrophic fires, which have important implications on public safety, ecological resilience, and biodiversity. And while we can't stop this problem overnight, we can start to protect people and nature with forest restoration. Controlled burning removes small trees and brush that ignite fire, thereby reducing the number of megafires, especially in fire-adapted forests. Prescribed fire is an effective way to reduce fuel loads and restore natural disturbance processes. With the U.S. Forest Service recent agreement to increase the amount of acreage burned by 2025, we're going to start to see an increase in prescribed fire use. However, the degree to which this fire mimics historic disturbance patterns should be evaluated to set desirable conditions going forward. Implementation is sometimes focused on the idea of acres rather than maintaining these historic disturbance patterns. And I won't go into too much detail of the monitoring crew itself. Joe and John touched on that earlier, but one of the main driving goals for the crew is to understand the effectiveness of prescribed burning. Questions that we ask ourselves: how does prescribed burning practices change across jurisdiction and across fuel type? How effective are these burns at reducing fuel loading and returning fire back to the landscape? And again, as Joanne touched on earlier, we have quite a large range of monitoring plots across the northern and central Sierras. However, for the focus of my talk, I'm just going to focus in on the Inyo National Forest, specifically on the Springs Fire. This area has an interesting patchwork of successive burning with variable severity, extent, and seasonality of prescribed and controlled burns. In late July of 2019, the Inyo National Forest contacted us about the potential to work on the Springs Fire northeast of Mammoth Lakes, which was being managed for resource benefit. I think Lee Turnay is also going to talk a little bit about this collaborative effort later on. Here's the location of the 2019 Springs Fire. 5,000 acres burned, designated by the red hatching. And you can see a little yellow box. This is the Indiana Summit research area just south, kind of bordering the bottom area of the perimeter. We worked closely with on-the-ground fire suppression and burn teams tasked with managing fire in order to sample forest and fuels condition immediately before and immediately after the fire occurred. The focus was on areas within the predicted fire perimeter that have been treated with prescribed fire in recent years. Sites were established across a treatment array such that different times since last fire were surveyed. The forest is comprised of Jeffrey pine and has a very homogeneous stand structure across the whole area. This really allowed us to hone in on differences of variable fuel loading and how those fuels influence fire behavior. Collaborating with fire crews was a vital piece to accomplishing this work. And honestly, we couldn't have done this work without it. We exchanged knowledge with hotshot crews by teaching them how to assess forest metrics and quantify fuels. And in exchange, they taught the crew more operational aspects of the fire, how to conduct certain ignition patterns, and how fire behaves across the landscape. To understand the effectiveness of prescribed fire and overall ecosystem condition, we conducted common stand exams before the burning occurred. We quantified overstory and understory tree diversity and density, shrub and herbaceous cover. We conducted a full botanical survey and looked at surface woody fueling. And here we can start to see some differences across different burn treatments. With more recent time since last fire, we start to see more forbs and less shrub cover. In the top left, we have the control area. This area had no prior burning. And then you can see successive differences with time since last fire. In the bottom right, we have our most recent prescribed fire, which occurred in 2013. We're starting to see differences in fuel conductivity as well as fuel type across these different treatments. But how does fire behavior and consumption vary between these zones? This was the beauty of this opportunity, and we were able to get on site right before the burn, quantify fire behavior indices during the burn, and get a more accurate fuel consumption measurement 2 weeks after the burn. We can start to see some subtle differences across this treatment type. The more recent 2013 and 2010 burns had slightly lower fuel loading than the 2007 and control areas. And this variation seems to be driven primarily by 100-hour fuels. However, as you can see, the overall fuel loading was quite minimal in this area, and these differences are quite subtle. To assess how fire behavior and consumption varied across the landscape, we're able to quantify plot-level fire behavior indices. This really helps us understand whether actual fire behavior matches with expected fire behavior modeling. Our fuels data fed and some of the indices we collect are quite simple: rate of spread, flame length, flame height, as well as weather data. Our fuels data fed to the air quality monitoring team and Lee, who will talk about this a little bit later, which resulted in more accurate and credible air quality predictions. However, I do want to note we understand the limitations of these limited fire behavior indices and hope to increase the technological capacity during burns to better quantify fire behavior. We were unsuccessful at getting any data during the night burns as well, which was a bummer, and that area did burn a little bit more successfully. Here, I have a little video, but will it play? Here's an example of a video that we have for one of the plots. And these, for all of the plots that burn during the day, we have video and pictures of the fire burning through them, which is really exciting. Understanding the post-fire environment is as important as we conduct more prescribed burning into the future. Like Joe addressed earlier, we need both long-term and near-term monitoring. So we were able to do an initial assessment 2 weeks post-burn, and again, 1 year later this year, with the hopes to continue monitoring multiple years after burn to assess understory diversity, tree health. Our initial survey included hazardous fuel consumption, initial fire-induced tree mortality, and burn severity. Our burn severity strata were substrate, which we looked at the effects to soil and ground fuels, understory, looking at the effect on grasses, herbs, and forbs, and overstory relating to scorch, torch, and bulb char. And here's a quick photo comparison of the burn effects of the different treatments. To the left, we have the 2007 prescribed burn area, which showed a little bit higher fuel loading, but we can see it was kind of overall fuel consumption was quite minimal and pretty similar to the area with no prior fire. The Springs Fire presents a unique opportunity to conduct real-time collaboration between scientists and managers. Reintroducing fire is important to restoring forest health and resilience. And with this data, we can start to better inform land managers. We'll have an improved understanding of stand characteristics driving this fuel consumption. Questions that we can start to answer. Are post-fire conditions closer to the natural range of variation? And how are these fire effects modulated by intensity and frequency of repeat burns? I wish I could provide a little bit more quantitative analysis with you all. I just got back from the field 2 weeks ago, so I'm currently starting to analyze data to really answer these questions. And we can start to scale up and look at differences across prescribed burns. I just wanted to show this example real quick. Here's some drone imagery I helped collect a few weeks ago with Derek Young, UC Davis researcher, and Jeff Carl, an Inyo National Forest fire ecologist. To the left, we see a drone image of the Springs fire. And to the right, we see the 2018 prescribed burn near Crestview. And this area is about 15 miles as the crow flies from the Springs fire. However, what's interesting is Crestview had a very different effect than the Springs fire. It had higher tree mortality, but what's interesting is that it burned at low intensity, similar to the Springs fire, low flame lengths, low flame height. Though the main difference was this thick duff and litter layer that increased the residency time and led to a lot of tree mortality. Monitoring the effects of prescribed fire is vital for fully understanding the best approach for achieving management objectives. We can start to parse out effects of climate, topography, moisture gradients, and vegetation on fire behavior and overall fire severity. The beauty of this program is the large amount of data we have collected and will continue to collect, and the questions that we can start to answer. Already, we have many interdisciplinary collaborative partnerships with folks at UC Davis and across the Forest Service. We're working with collaborators at UC Davis to quantify fuel loads using drones and AI. Derek Young is a researcher that is currently using high-resolution fuels mapping using computer vision technology and drone imagery. So the data and imagery collected with the monitoring crew on the ground will actually be able to train the neural networks to quantify these fuel loading across spatially extensive high-resolution data sets. In addition, following these areas through time, we can start to assess forest health implications and biodiversity implications. So that's all I have for you today. I just wanted to thank all of our collaborators, Hugh Safford and John Williams, and Joe Restiano working on this project, as well as Chance Traub and Jeff Carl working on the Inyo National Forest, and Derek Young, who has been working with us in data collection. All right, thank you, everyone.
Great. Thanks, Ashley. That was a great presentation. We still have a little bit of time left in your slot, so if anybody has a question for Ashley, now would be a great time. Ashley, I have a quick question. It just occurred to me when you're talking about the post-fire, the coming 2 weeks after the burn and 1 year after the burn. Now you've done that, and I actually have, despite working with you, I haven't had a chance to ask, like, anecdotally, forget the data, the hard numbers, but what has been your perspective, both in the Springs and elsewhere, where you've been able to come back 2 weeks and a year later? Are you seeing some real differences, or do you need more than a year's time for that second return?
Yeah, that's a really good question, and I think sorry, just weird noise. Really gets at the fact that I think both that 2-week survey and the 1 year survey is so vital to really understanding what's going on across the landscape. Our initial survey really allowed us to understand that initial severity, what was actually consumed, and how much hazardous fuel was consumed on the landscape. Over the winter, a lot came down, but it was hard because the Springs fire, I feel overall just had such low fuel consumption that I don't know if we hadn't come back 2 weeks after. I'm interested in, what we would have seen. But that being said, coming back a year after was really important for understanding how looking at tree mortality and looking at kind of the vegetated response.
Cool, thanks. Anybody else, any questions for Ashley?
I have a question.
Go for it, Joe.
Hi, Ashley. I'm just curious, now that you're becoming such an expert in Inyo, are you able to see different qualitative effects compared to the other recent wildfires like the Clark Fire or other fires in the Indiana Summit area? Because I know that there's been a lot of recent burning done by wildfire there as well. And I'm just curious to see if you had any insight.
Yeah, I know it's been really interesting to be out on Inyo National Forest because of, yeah, the variation in severity and severity in fires, both prescribed fire and wildfire. The Indiana Summit area is very interesting. I know, I think Malcolm North has spent a little bit more time there, but I went to go see that fire scar, and it's wild. There is huge trees that are just completely dead. It burned really hot there. And sorry, I just saw a little comment. I think, yeah, keeping monitoring going in these areas, the Crestview especially. I know that was a really interesting fire to go see. That occurred in 2018. And I know I've talked to a little bit, some fire folks on the Inyo, and the 2018 Crestview fire burned really hot, had a lot of tree mortality, high severity burn area, and kind of cut down a lot of the potential to burn, made it harder for folks higher up to kind of allow for further burning. And yeah, I think it's pretty crazy to see, such an area that has such similar vegetation type, but just subtle differences in topography, and duff layer to have same fire behavior, but end up, having such different implications on tree mortality. So I think continuing monitoring in these areas is super vital to really understand the intricacies of how fire affects tree health and overall diversity in these areas.